This one's for posterity. So my example at the front with "but" here says that the order matters. It says in previous lessons we've learned the following rules. So here's all the stuff that we learned. It wants us to walk through a bunch of examples, but it's Friday, it's last block. I'm just going to give you the punchlines. So although warm-up number 1 and 2, they're doing what I just did in front of you with Jake. They want you to realize, hey, there's a problem. The order makes a difference. Same with warm-up number 3. Same with warm-up number 4. Let's go to page 61. Page 61. Justin gets a smile on his face whenever he gets to turn pages that are blank and doesn't have to worry about filling them out. Now it says this, in general, the order does not matter. You can be sloppy when 2 slides occur, 2 expansion compressions occur, or if you're sliding horizontally and stretching vertically, or stretching horizontally and sliding vertically, as long as you're at right angles to each other. You know what? I don't really worry about this. Steph, what I'm going to say is I'm just going to get in the habit of always doing it in the right order. And then I don't ever have to ask, does it matter or not? I'll just learn to always do it in the right order, and then I'll always get the right answer. Okay? It really matters when you're doing a slide and a stretch in the same direction, horizontally or vertically. Here is the order that we are always going to do things. We are always going to go expansions, compressions, reflections or flips, and then translations or slides. And you can see it's ERS or ERT. It's alphabetical if you're looking for an easy way to remember the order. Expansions, compressions, reflections, slides. Okay? Always that order. Expansions, compressions, reflections, slides. So example 1 says, describe the series of transformations required to transform graph A to graph B. The first thing I'm going to ask is, were there any expansions, compressions here? I don't think that one of these graphs is fatter or thinner than the other graph. Were there any reflections here? I think definitely what type of a reflection, horizontal or vertical. I'm going to make a little note here, horizontal reflection. Now it's possible there was a vertical reflection, but because it's the parabola and it's symmetrical, and if you flipped it vertically on its side, you couldn't tell. We're not going, like you could say, well, I could have flipped it and then flipped it again 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 and end up back where I started from. We're always just going to assume, Hannah, the simplest possible case. We're not going to say, well, yeah, I guess technically there could have been 8 vertical flips that all canceled each other out. Forget it. We're just going to say, I don't think there was a vertical flip. Slides now. I think the easiest point to track will be the vertex. So what's the coordinate? Oh, A is where I started from at 0, 0. And we've ended up over there. How has this graph been moved? How has it been moved? You know what? Let's do horizontal and then vertical. So 2 left, 3 up. I can even write the equation now, assuming the original equation was our good old generic function. I would first of all do a horizontal reflection. That's replacing what with what? Well, horizontal, I'm replacing what automatically if it's horizontal? X with, okay, so that line would look like this. And then 2 left, that's replacing X with what? He's having a tough time. He needs your help, okay? Help me keep him awake. Sorry, replacing X with what? I'm losing some of you. I'm going to go like this. Okay. For this here, this would be replacing X with negative X. What about for this here? It's left, right, so it's horizontal. Replacing X with what? X plus 2. What about this? Replacing Y with Y minus 3. So I think my new equation would look like, well, first of all, I would replace the X with X plus 2. Now, look up. A lot of students will do that, and it's wrong. Is your original X completely negative? then what you replace it with should be completely negative. You have to put in brackets. And then the final replacement that looks like Blaine is y with y minus 3. That's the equation. Although, Kellen, I'd probably plus the 3 over to the other side if I gave this to you as a multiple choice question. Okay. Example 2. It says, describe the series of transformations required to transform graph A to graph B. All right. First thing I look for is expansions, compressions, in that order. How wide is graph A? How many squares? 4. How wide is graph B? How many squares? Horizontal expansion. Oh, horizontal expansion by 2. They've replaced x with 1/2 x. Vertically, how high is my original function? 4. How many squares high is it? 4 squares high grand total. Vertically, how high is my big graph B? I think also 4. Has there been a vertical stretch at all? No. Reflections. You know, this is so symmetrical, I can't tell. They could have flipped it. Could you tell? Let's assume not then, because they could have flipped it and flipped it and flipped it and, yeah, forget it. We always assume simplest possible case. Okay, slides. I think the easiest point to follow around here is going to be the center. Where did the center end up? Right there. And the reason I picked that is because the center, since it's 0 left, right, would not be affected by that transformation. So I should be able to just count. What do you get? Count, boys and girls. What do you get? I'll give you a hint. 4. 4. I think I said we're going to do horizontal x's first. Yes. 4. 4 left. That means they replaced x with x plus 4. And Luke? 7 what? I thought you said it. Sorry. Oh, you did say it. Yes. 7 down. That means they replaced... Oh, I don't want to draw the arrow there, Mr. Dueck. Well, whatever. That means they replaced y with y plus 7. Now, if I'd picked the corner, that would have been way tougher to figure out, because the corner, if I counted sideways to this corner, I would get 8 squares. Now, why would I get 8 squares? Because first it was expanded by 2, and then it went 4 left. So I always try and pick x or y intercepts. The origin is a very nice one to move around if you can. Okay. How would I change graph A to graph C? Well, expansions, compressions first. How wide is graph A? Did I have to write what? I couldn't hear you. Did they ask us to write the equation, or did they just say describe? They said describe. Here I wrote the equation because there was room, Luke, and I want you to get practice. Here I don't have room. So, by the way, though, you know what it would be? Y plus 7 equals f of 1/2 bracket x plus 4 close bracket. Okay? Hey, Luke, how wide is this one compared to this one? Same? What about, has there been a vertical stretch? What? So vertical expansion by 2, that means they replaced y with 1/2 y. Reflections, I can't tell. Too symmetrical. Slides, well, here's the center of this one. How has it been slid? Seven or 6? 6 what? 6 left. That means they replaced x with x plus 6. All right. Hey, how many up? How many up? How many up? We're back now. I think they, write the transformation, Mr. Dueck. I think they went 4 up. They replaced y with y minus 4. Turn the page. Okay. It says, describe which transformations are applied to a graph of the function when the following changes are made to its equation. And then it asks, does the order matter? Honestly, I don't much care. I'm always going to do it in the correct order, except sometimes they will give you a question where they demand that you do it in their order. For example, what does it say in example 4 in bold font? Okay, what they're saying is, do it our way. So if they do say that, don't worry about the proper order. They have a reason for doing it in the wrong order. They want to guarantee that you get a certain shape, Steph, is probably what's happening, okay? Anyways, replace x with 3x. What's this do? Vertical or horizontal? Horizontal, expansion by 3 or compression by 1/3? Compression by 1/3, but I'm going to write that down. Replace y with y plus 4. Vertical or horizontal? Vertical. 4 what? Down. Replace x with 2/3 x. Vertical or horizontal? Horizontal. Expansion by what or compression by what? 3/2. Is that bigger than 1 or smaller than 1? So expansion by 3/2. So you can figure it out, right? Replace y with negative 3y. Two things. Vertical or horizontal? Vertical, expansion by 3 or compression by 1/3? Compression by 1/3. And what else, Martin? Vertical what? Reflection. X with x plus 2. 2 what? Left. Okay? By the way, because you're doing a horizontal and a horizontal, this one, the order would matter. Here, the order wouldn't. It's when you have more than one thing going in the same direction. I really don't care about that. I'm just always going to do it right. Okay? It says, a graph of the parabola is shown. This is the parabola x squared plus 1. It says, do the transformations this time in the order shown, even though technically they're in the wrong order. I'm going to follow their instructions, Alex. So it says a horizontal translation to the left 2 units. What's the replacement that I would do for a horizontal translation to the left 2 units? I'll give you a hint. It's horizontal. Replace x with what? X plus 2. That's 2 left, right? So in my equation over here, I would have this. Y equals, instead of an x, I'd have an x plus 2 and then a squared plus 1. Right? Justin, what's the next thing they want me to do? Okay, I got to think about this because I always get this wrong. We're reflecting in the x-axis. So my arms are the x-axis. We're spinning around here. Is that a vertical or is that a horizontal reflection if we're spinning in the x-axis? Vertical. So this is going to be vertical. Replace y with what? Negative y. I'm just going to write negative y equals bracket x plus 2 all squared plus 1. I'll do my simplifying in junk math at the very end. Okay. Connor, what's the next thing they got me doing? Vertical, y. Factor of what? So replace y with what? No, I got to be fussy. He said replace y with 4. No, with 4y. See, if you didn't do that, you'd have a negative 4 sitting here. It's going to be the negative stays. 4y gets the y gets replaced with a 4y, and that equals x plus 2 all squared plus 1 dropping down like a domino. This is how they can force you to get a specific equation. They can walk you through it step by step. Kellen, what's the last one? Vertical, y. By the way, do you see why I'm trying to hammer that? It really cuts down on your thinking. 3 what? Down, what will I write? Replace y with what? Y plus 3. So the negative is going to drop down. The 4 is going to drop down. Again, the most common mistake, Kellen, I see kids do that. But if we're replacing the y with y plus 3, and if the original y had a negative 4y in front of it, the y plus 3 better have in brackets a full 4y in front of it, equals x plus 2 all squared plus 1. Okay? Could I FOIL this out, gather like terms, get the y by itself? Yes. Will I? No. I'm not going to waste my time. I could, though. Instead, they did also ask me to graph this. Now, they wanted me to graph each transformation. I'm going to do the whole thing in one fell swoop. Ready? I'm going to start with the vertex because it's the most important point. And I'm going to zoom in. Is that going to let me also still see the? Yeah, it will. Okay. So starting right here, what's the first transformation, Chelsea? I can't hear you. I'm sorry. To what? Can you say, did you say to left? I'm just going to say to left. Boom. I'm going to hold my pencil right there but not put a dot. What's the next one? Vertical reflection. So instead of one up, one down. Hold my pencil above there but not put a dot. What's the next one? Vertical compression by 1/4. Instead of -1 high, I'll be -1/4 high. Bleh, but I'll eyeball it. About there-ish. What's the next one? Down 3. 1, 2, 3. I think I'd end up right there. Bleh, I don't like that hanging in midair, but I dealt with it. Okay. Let's pick this point right here, just to the left of the vertex. First one, to left. 1, 2. Hover my pencil. Reflect in the x-axis. That's a vertical reflection. 2 down instead of 2 up. Compress by a factor of 1/4. Well, 1/4 of 2 is a half. And then 1, 2, 3 down. Greg, I'm going to eyeball my first vertex and I'm going to say, I'm going to move it just a tiny bit up so I can see the parabola shape a little bit better. Mr. Dueck, should we always do the graphs in pencil? Yes. I guarantee at least once, if you're doing these in pen, you're going to be in for a nightmare on a quiz or a test. And I'm sorry, I don't put extra graph paper on these. Luke, I'll do this one to the right. To left. 1, 2. Reflect. Instead of 2 up, 2 down. And then vertically compress by 1/4. Instead of 2 down, half down. 1, 2, 3 down. Oh, I'm starting to get kind of a little parabola-ish shape there, starting. And this parabola should end up opening downwards because it did undergo a vertical reflection. Here, this looks like -2, 5. To left. What's the next one? Vertically reflect. Instead of 5 up, 5 down. Take 1/4 of that. Yuck! What's 1/4 of 5? 1.25, still negative. And then 1, 2, 3 down. Now, Hannah, I'm going to get a little bit clever. Is a parabola symmetrical? Then I'm betting the other point is right there, because it's symmetrical. And I'm going to stop, because this is really a yucky graph. I will not ever give you one with this many decimals. You might get one with 1 or 2 decimals, but not where everything is a decimal hanging in midair. Not because the math is too hard, but honestly, Kellen, because it's too hard for me to mark. I really can't tell if you're at 0.25 or 0.5. It's really tough to spot. Okay? But could we handle it? Yeah. Except this was in the wrong order. Now, we followed their order. Okay? Homework part number 1. Number 1. 2 is good. I'm just going to go with 1 and 2, and we're going to jump to lesson 10. This is where we're going to get into the meat and potatoes. Go ahead. You can open both of them if you want to. Okay. Thank you. So we're on lesson 10. Now we're going to try and generalize this. Okay? Martin, here's our generic equation, this thing, where each of those numbers means something. What does the A mean? Vertical or horizontal? Vertical, and it can mean two things. If A is negative, what does that mean? Vertical reflection. Otherwise, if A is a number, it's not backwards because it's already been moved over. That's your stretch, vertically. What does the B mean? Vertical or horizontal? Horizontal. It's expansion, compression, and it is backwards because it's next to the X. Oh, and if it's negative, that also means a horizontal what? Reflection. See how all this is coming together now? What does that mean? That's a left-right slide, and it's backwards because it's next to the X. What does that mean? That's up-down, and it's no longer backwards, Chelsea, because it's no longer next to the Y. It's been moved over. Okay? That's what this is saying. And to do these, what we're going to do is expansions, compressions, reflections, slides. Do I want to do that one there? Nope. Nope. I want to jump to example 1. This is what we're going to give you. All right? Here is a sketch of y equals -2 f of x minus 3 plus 1. And this is just some generic shape. What I'm going to do is I'm going to list the transformations. And if you were doing some of these in your head, I strongly encourage you. This is the point, Connor, where it's worth taking 1 second to make a list. Trust me. But we're going to list them in the correct order. So the first thing I'm looking for is any expansions, compressions. Now, when I say that, Alex, what I'm really saying is find coefficients. That's what expansions, compressions are. So have I got an expansion, compression here? Vertical or horizontal? Vertical. Expansion by 2, compression by 1/2. Which one? Let's see. Everything's backwards if this is next to the Y where it belongs. Is it next to the Y where it belongs? Then it's not backwards. Vertical expansion by 2. Is there a horizontal compression or expansion? And what I'm really saying, Hannah, is there a coefficient in front of the X? No. Next thing I look for is reflections. Now, when I say reflections, you know what you're really looking for? Negatives. They're pretty easy to spot. There is a reflection, vertical or horizontal. Vertical reflection. Is there a horizontal reflection? Is there a negative in front of the X? No. Slides. 3 what? 1 what? And I'm just going to move this over because I'm going to magnify my graph, and if I can't see, that doesn't do me much good. And now we're going to graph it. We've listed the transformations in the correct order. Here we go. I'll start right here. Greg, vertical expansion. So this point right now, how low is it? -2. Vertically expand that by 2. -4. I'm going to hover right above there. I'm not going to change the x's. I just doubled my height. Vertical reflection. Right there. Hover my pencil. What's the next one? 3 right. 1, 2, 3. What's the next one? 1 up. That point ends up right there. It is connecting the dots and counting. Complicated connecting the dots, but really, I kind of like this. This is as close as you'll ever come to coloring in Math 12. Greg, which one would I do next if I was smart and clever? Yeah, the one that's connected. Like, in other words, don't be silly and start jumping around all over the place. Let's do this. Vertical expanded by 2. So how high will it become? 0, fancy word, invariant. Vertically reflected. Oh, still 0. That's kind of nice. Then what? 1, 2, 3, and what? 1 up. Were the originals connected in a straight line? Then I'll connect these in a straight line. Next one. How high? 4. Vertically expanded by a factor of 2. 8. Then what? -8. Then what? 3 right and 1 up right there. Now these ones were connected with a curvy shape, were they not? So, Justin, I'm going to connect them with kind of a curvy shape, because that's what they were originally. Hey, Justin, what's the next point that I would do? I think this guy. How high? Right now. Vertically expand that by a factor of 2. 0. Reflect it. 0. And then what? 1, 2, 3. And they're connected curvy. Connect them curvy. Oh, last one. Ready, Alyssa? Vertically expand it by 2. 10, which is not on my graph, but I'm just going to remember 10. Reflect it. Negative 10, which would be down here. 3 what? 1, 2, 3. 1 up. You know, that's going to be negative 9. My graph goes to negative 8, but I think I can eyeball 1 point below negative 8. Okay. Now, if you get 4 or 5 points off the graph paper, you've messed up. Stephanie, once in a while, you might have 1, at the most 2, because I can't keep everything fitting on the graph paper. It just doesn't let me do neat, interesting shapes. But if you're getting 4 or 5 off the graph paper, or 4 or 5 decimals, I won't give you questions like that. Oh, and they're connected kind of, sort of curvy. Let's see, this points to the inside. I think this points to the inside. So I think it curves kind of like that, I think. Sorry? There, that red shape is that graph. Okay. That was so much fun. Let's try another one. Mr. Dueck, this is like coloring. Okay. It says, consider our generic f of x equation. In each case, determine. So here's another multiple choice question. Yeah. So back to here. Consider this function. It wants us to list the replacements and then get the equation. If I was giving this to you, it would be multiple choice, and I would simply say, what's the equation? So horizontal compression by a factor of 1/4. Horizontal x. Replace x with 1/4 x or 4x. Which one? Everything's backwards. And then vertical translation 5 units down. Vertical 5 down. So if this is my original, can you see it? Y plus 5 equals f of 4x. Now I did that all in one step because I only had one horizontal and one vertical. If I have more than one horizontal or more than one vertical, we're going to do this in multiple steps, because otherwise you'll make a sloppy mistake. So here we go. B, vertical. Vertical. Compression by a factor of 3/5. Replace y with what? 5/3 y. Yep, everything's backwards. Reflection in the y-axis. Okay, I got to think about this. The y-axis is vertical, so we're reflecting about the y-axis. Is that a vertical or is that a horizontal reflection? And you better tell me soon before I get too dizzy. Horizontal? I might need to get underneath the table. Wow. Okay. So I think we've replaced x with a negative x. It's a horizontal reflection. And then a horizontal translation 2 units left. That's replace x with x. Everything's backwards. Okay. Martin, do you notice this time I have 2 x things? I'm going to go in 3 steps, step by step. So the first one would look like this. 5/3 y equals f of x. But that's not my final answer. I would replace x with negative x. That would look like this. 5/3 y equals f of negative x. But that's not my final answer. I would then replace the x with an x plus 2. This is going to be 5/3 y equals f of, there's the negative, and the entire x plus 2 has to be negative. I have to introduce some brackets here. If I don't, not correct. Is that better? Sorry. I can even tell you, if this was multiple choice, what your other four answers would be. A 3/5 there, a minus there instead of a +2, and forgetting the brackets, because those are the three most common mistakes. Okay? Turn the page. Example 4. This is where we're going to run into the first problem. Okay? And the first problem is this. What's the correct order? What did I say? What do you do first? Expansions, then? Reflections, then? Slides. That order only works if inside the function, if you have a coefficient in front of the x, everything is factored. In other words, I need brackets here, much like that. If I don't have brackets, if I have the number in front distributed, the order no longer works. This is where I said earlier, I used to teach Kim 2 different orders, and I found kids got confused. What I'm going to say is, if it's not factored, then factor it. In fact, here's my little reminder. This is my little mnemonic device. Anytime I see a coefficient, whoop, little alarm bell is going to go off every single time to remind myself I better check to make sure that it's factored. And you better believe for the next 5 days, you're going to be hearing that over and over and over. And if it scares you to remember, then I'm good. So before I can do this, I need to rewrite this in the proper form. Y equals f of. I need to factor that 1/2 out. That's going to give me an x here. There's going to be a plus here. Now, look up. What you're saying, Chelsea, is when I go 1/2 times this number, it gave me a 3. Please don't be sloppy with fractions, because a lot of them will be fractional coefficients, because those are expansions. Right? You factor out a 1/2, you're dividing by 1/2, same as multiplying by 2. So this is a great question, because a lot of kids would look at this and they would say, okay, expansions, compressions, coefficients. Is there something in front of the y? No. Is there something in front of the x? Yes. And they would go, okay, horizontal, expansion by 2, compression by 1/2. Which one? They would write that down. And they would say expansions, reflections, check. Then they would move on to the next one. Sorry, I said expansions, reflections. Expansions, compressions, check. Then they would move on to reflections. When you're looking for reflections, what are we really looking for? Do you remember? Negatives. And they would say, I don't see any negatives there. Check. But a whole bunch of them would then go, oh, 3 left. And it's not 3 left. How many left is it really? Huge difference. 6 left. And why? Because it's no longer next to the y. It's not backwards when it's on this side. Okay? This is where I'm going to get some of you. I guarantee on your test, on your quiz, I guarantee I'm going to give you some of these that aren't factored. Okay? Now, we don't have to be so fussy when we have this, because if we have something in front here, it's already factored. It's taken care of. It's when it's inside the x brackets. For example, if I glance down here, this is not 12 right. I'm going to have to factor out the 3. It's 4 right, which makes a huge difference. 12 right, 4 right. In fact, 12 right, you're probably off the graph and freaking out. 4 right, you're probably still on the graph. Anyways, now that we've made our list, let's connect the dots. So we'll start here. Horizontal expansion by 2. So instead of -3, what will it end up at? -6, and I'll hover my pencil. 6 left. 1, 2, 3, 4, 5, 6. That's off my graph, and 8 down. I'm not going to worry about that point. Now, if I get 4 or 5 like that, then Kellen, I probably made a mistake. 1, won't freak out. I can't get all of these to fit on 10 by 10 graph paper. And I don't want to do it like a 30 by 30 graph paper. That would terrify you guys. Ah, it's taking up the whole page. So, you know what? I think I'd do this point next. Horizontal expansion by 2. So instead of 2 left, instead of -2, where's it going to end up, Luke? You say -4? So I can feel your -4. Okay, and then 6 left. Oh, that's going to be -10. 8 down. Okay, that fits right there. What's the next one I'm going to do? That guy. Horizontal expansion by 2. That's a trick question. Ain't going to go anywhere. 6 left. Right there, -6. 8 down. Oh, it was 8 high to begin with. 8 down is going to be, hey, this is my new x-intercept. So how could I give you a different question? I could maybe give you this transformation, give you this graph, and say, what is the coordinate of the new x-intercept? Right? Trying to think of how I can make this a multiple choice question. Were the original 2 connected? Straight line? Then connect them straight line. Oh. Oh, heck. Cheat, Mr. Dueck. There. What's the next point that I would pick? This guy. Horizontal expansion by 2. 6. 6 left. Oh, 0. 8 down. Bonk. Right there. And connect them. Last one. Horizontal expansion by 2. Oh, to the 8 to the right. 6 left. That's going to be at 2. 8 down. This one I got to count. 1, 2, 3, 4, 5, 6, 7, 8. Right there. And connect them. That black graph, that highlighted graph, is the image of the original, although there's one point down there somewhere. So really, Kim, what's the one thing we have to remember besides staying awake and not getting under the desk? It's going to be, please make sure if there's a coefficient in front of your x and there's a minus or a plus next to the x, it better be factored in brackets. I'm telling you right now, I'm going to try and get you. Says, complete the following. The square root wounded seagull graph has been transformed into this. Oh, alarm bell right away, because I see a coefficient and it's not factored properly. Get used to it, boys and girls. Okay? I'm going to rewrite this, Chelsea. It's going to be g of x equals, I'm okay with the -2. I'm okay with the square root. I'm okay with the 3. What I'm not okay with is the x minus 12. That's going to be an x and a minus and a what? 4 plus 5. Now that we've written it in the proper format, let's fill in the blanks. This has been transformed by compressing horizontally by a factor of what? What's the horizontal compression in this question? Horizontal. What's the horizontal compression? Yep. No, you need to stay awake. I know. That's why you retired earlier. 1/3. Stretching vertically by a factor of 2. Reflecting, well, what kind of reflection? Vertical or horizontal? It's a vertical, and that's in which axis if we're reflecting vertically? Okay, reflecting in the x-axis. Translating how far up? 5 units up. And blank units horizontally to the... Luke! How many? 4. Right. Did you look down at your hint? Okay. Turn the page. Number 2. Okay. Number 3. Oh! Alarm bell. See this one here? Gotcha, Claire. Right? That one there is not 8 right. You know what it's really going to be? 2 right. Okay? That's the only tricky part, I think, with this, once we put everything together. In fact, kids have told me that multiple combined stuff is actually easier than the other stuff because you get to go more sequential and it kind of makes more sense. Now, in number 4, they want you to go in the order given. So even if they're giving it to you in the wrong order, follow their instructions, okay? So number 4. 6, skip 5. And 9. Okay? We're done the bulk of this unit. I do have 2 more lessons. One is actually pretty easy. One, at first, is going to seem difficult, but you're all going to get the hang of it by the time it's done. And then we're done. I am on Monday going to have for you, I believe, a take-home quiz. What I'm going to have for you is some kind of a squiggly function, and then 6, I think, different questions ranging from a really easy transformation with maybe only 1 or 2 things, all the way up to one of them is going to have 6 things. It's going to have a vertical reflection, a horizontal reflection, a vertical stretch or expansion or compression, a horizontal expansion or compression, a left-right slide, an up-down slide. That's as much as I can do. There's only 6 things you've learned. Okay? Is that all right? Hey, I think you got 20 minutes. You can probably get the homework done in class and have no homework for the weekend because I haven't given you much yet.